Problem number 6. Write the double integral over r of y over x dy dx in polar coordinates, where r is this region here, between y is equal to 0, x equal to 7, and x squared plus y squared is equal to 64. Okay, so the main thing we have to do here is figure out bounds in terms of theta and r for this region here. Theta runs from here to here. We need to figure out what that theta value is. We can see that the first theta value, the lower theta bound, is going to be 0. And also for a fixed value of theta, what are the allowable r values here? Well, x squared plus y squared is equal to 64. X squared plus y squared is r squared is 64. That's r is equal to 8. So 8 is an upper bound here on theta. Sorry, on r. Now, that leaves theta upper bound, r lower bound. The r lower bound is going to come from x is equal to 7. Well, x is r cosine theta. So r cosine theta equals 7 here. Divide both sides of this by cosine theta. R is equal to 7 over cosine theta. So our lower bound here is going to be 7 over cosine theta, or you can write that as 7 secant theta. As for theta, okay, what theta corresponds to this angle right here? Well, let's think about this point right here. This point has coordinates. What are the coordinates of this point? The x value is 7. And then the y value needs to be such that 7 squared plus y squared is equal to 64. And so y squared is going to be 64 minus 49. Y is the square root of 15. So then, how do we relate x, y, and theta together? Tangent of y over x is, I wrote that backwards there. Tangent of theta is y over x. I meant to write tangent inverse of y over x is equal to theta. Okay, so we have y and x here. Arctangent of root 15 over 7 is equal to theta. So this is our upper bound on theta right here. And let me say here, sometimes we have to worry about what quadrant we're in for arctangent and stuff like that. We're in quadrant 1, everything's okay. So then for our final answer, so this is equal to theta runs from 0 to arctangent of square root 15 over 7. R runs from 7 over cosine theta to 8. R dr d theta. And then the last thing we have to do is convert y over x here. But we can see here y over x is tangent theta. And so this is our final answer for converting this integral to polar coordinates.